Hello students, now we are going to see conductor and their properties. Till now in the unit 3 we have seen what is a current, what is a current density, what are the types of currents we are having, that is convection current, conduction current and displacement current. After that we have seen what is a continuity equation, integral form of continuity equation and differential form of continuity equation. And we have seen the relation between convection current density and charge density, rho and velocity. So while discussing this, the properties of your conductors, in this we are going to see the resistance and the power. So for discussing to understand these properties of conductors, we are going to use the relation between conduction current and that is of current density, charge density and the velocity. We got something like, we got some equation J is equal to rho into U. We got this relation J is equal to rho into U. This is a relation between your current density, charge density and velocity. This equation we are going to use in this properties of conductors. Let us take one conductor whose length is L. Let us take one conductor whose length is L. For example, this is a conductor whose length is L, which is supplied with or it is fed with some voltage, that is V. This is a supplied voltage V. This conductor is having some free electrons. Because of this voltage, there is electric field. This electric field is indicated with E is equal to V by L, electric field. Because of these fields, this electron tries to move towards your positive direction or positive polarity of your battery. Generally, there is a statement that because of this field, this electron gets infinite velocity and it tries to move in the direction of your positive polarity. But practically, this is not the case. Practically, it won't get infinite velocity because of this field. The velocity which the electron acquired, this is the electron, let us consider this is the electron. The force or the velocity which is acquired by this voltage, this may be decreased by colliding with the adjacent atoms. Here you are having some adjacent atoms in the conductor. While traveling, this electron, this is the electron, this electron may collide with this adjacent atomic lattice or atoms. Because of this collision, the electron velocity of electron gets reduces. So it will move at average or with a drift velocity. It will not move with an infinite velocity. The velocity by which the electron moves or it moves towards the positive polarity, that velocity is called as average velocity or drift velocity. That drift velocity is indicated with UD. Normal velocity is U and drift velocity is UD. According to the Newton's law, the average change in momentum of the free electron must match with the applied force. This electron may experience some force. That force is equal to F is equal to generally Q into electric field. Here Q for electron, this Q becomes minus E into capital E. Here E is nothing but your charge of the electron, minus indicates your negative charge. So F is equal to Q into E. Because of this field, this electron may experience some force. That force is equal to F is equal to minus E into capital E. So according to the Newton's law, the momentum of free electrons must match with the applied force. The momentum depends upon your force. If force increases, the momentum of electrons also increases. So according to this, F is equal to, the force is equal to, we can write F is equal to M into A, where M is a mass and A is a acceleration. This acceleration may be replaced with the distance our velocity, that is ud by t, which is equal to, here we are considering electron, so force is equal to, we can write here minus E into capital E. So from this, where this t is nothing but your average time interval between the collisions, this t indicates average time interval between collisions From this we can write ud is equal to, that is of drift velocity, ud is equal to minus E capital E, that is electric field intensity. This can be written as, here to avoid the confusion, let us consider this is a capital T. Capital T is it is an average time. So Et into capital T by small m. So this can be replaced with minus mu E into capital E. This is electric field intensity, where mu E is equal to Et by small m. This is called as, mu E is called as mobility of electrons. This mu is indicate mobility of electrons. This is a charge, this is a time, that this is your mass. Mobility depends upon your time and the mass and the charge of electron. If n is a electrons per unit volume, if n is a number of electrons, let us consider n is a number of electrons per unit volume, then here we can write rho E is equal to, that is of charge density is equal to number of electrons and their charge. Just wait a while. Okay, rho E is nothing but your, that is our charge density, n into small e. So from this we can write J is equal to, that is of current density. Current density J is equal to, rho E into U. Already we have seen the relation between charge density, that is of current density, charge density and velocity. Here rho E can be written as, just substitute in a place of U. U is nothing but velocity. Just substitute here. Rho E is equal to minus n into capital E, and the velocity is equal to minus E into E bar capital T by small m. So the total, it becomes minus minus, it becomes plus. So n E square capital E by capital T by m. So this can be written as J is equal to sigma into capital E, where sigma is equal to n E square capital T by m. If I replace this n E square capital T by m with sigma, then here you are going to get J is equal to sigma into E, where J is called as conductivity, units are mho per meter. sigma J is equal to sigma into capital E. Electric field intensity, from electric field intensity, E is equal to voltage by, that is the potential by L, and J is equal to I by S. By using these two, let us write here J is equal to sigma into E is nothing but your, we can write V by L. So from this J is nothing but I by S. J is equal to current density sigma into V by L. From this V by L, V by I can be written as L by S 1 by sigma L by S. So V by I is equal to rho into L by S, where V by I is equal to resistance, R is equal to rho into L by S, where rho is equal to 1 by sigma. Rho is called as resistivity, which is a reciprocal of conductivity. Rho is a resistivity which is a reciprocal of conductivity. Here we got resistance of a conductor, R is equal to rho into L by S. Now let us define for power. Power is nothing but it is a rate of change of energy or force times velocity. Power is nothing but your force times velocity or rate of change of energy. So P is equal to, we can write P is equal to F into, that is of force times velocity. So F dot U. So we can write F is nothing but your Q into E dash, where Q is equal to, Q can be written as rho is equal to dq by dV. If I consider volume charge density, from this dq can be written as rho v into dV. Then Q is equal to integration over rho v into dV. If I substitute in a place of Q this one, so P is equal to integration over the volume integration over rho v dV E dash, that is of U. So P is equal to the volume integration of rho v dV E dot U. Here you can write E, that is your electric field intensity, E dot, if I consider this rho v dV, rho v U and dV. Rho v into U is nothing but your, that is your current density. J is equal to, we got rho v or rho into U, that is current density is equal to charge density into velocity. So we can replace this with current density, integration or volume integration over E dash J into dV. This is a power. So power is equal to P is equal to volume integration of E dot J into dV. This is called as Joule's law. So P is equal to, we can write P is equal to line integration of E dot dl and surface integration of J dot ds which is equal to E dot dl is nothing but your, that is your voltage, and J dot ds is nothing but your current. So P is equal to V into I. By using this only, volume integration can be replaced with the line integration and surface integration. This single integration is replaced with the two integrations, one with the line integration and one more with the surface integration. So here we have considered E dot dV is equal to dl ds. So dV is equal to dl into ds. So here we have taken E dot dl line integration and J dot ds your surface integration. The line integration of E dot dl is nothing but your voltage, and the surface integration of J dot ds is equal to current. So by using the line integration, we have obtained the potential, and by using the surface integration, we got current. So while discussing line integration, the line integration is used to find the potential from the given electric field intensity. So that only we have used. This is a concept of line integration. Potential is obtained from electric field intensity. This is your surface integration. That is of current is obtained from current density. So in the next class we are going to see, this is about your current and current densities and conductors and their properties. In the next class we are going to see boundary conditions between conductor and free space.